Hi, my name is Alyssa Freeman, and I am a PhD student in the Math and Science Education program. Today, I'm presenting some findings for a project we have on graduate teaching assistants, or GTAs. GTAs are responsible for teaching many undergraduate courses, so our research lab is really interested in learning about GTAs so we can better support them in their teaching roles. Often, this occurs through professional development opportunities. So in this study, I was specifically interested in looking at STEM GTA's perceptions of discontentment, autonomy, and self-efficacy. Discontentment refers to the dissatisfaction GTAs have with their teaching. I was particularly interested in GTA's discontentment because it has been proposed as an important contributor for instructors to try new teaching practices and to also engage in professional development. However, for GTAs to try a new teaching practice, I anticipated that they also would need to be able to control or choose that practice, which is referred to as autonomy. I also anticipated that GTAs would need to have self-efficacy or confidence to try out that practice. So in this study, I was interested in exploring if there were relationships between GTA's perceptions of discontentment, autonomy, and self-efficacy. I collected quantitative data from surveys and qualitative data from interviews. And to show the findings for this study, there are icons in the middle to represent each of these ideas. The calculated correlation coefficients did not provide evidence of a relationship between autonomy and self-efficacy. There was evidence of a positive relationship between autonomy and discontentment, where the GTAs who reported having less autonomy or less control also tended to report less satisfaction. One GTA, Ben, described in his interview how he feels like he has a lot of autonomy and freedom to teach how he wants to, which he preferred since he could teach in a way that felt natural to him, which led to his satisfaction with his perceptions of autonomy. For the correlation between discontentment and self-efficacy, there was evidence of a negative relationship, where the more confident GTAs tended to report being more satisfied with their teaching. George described how now that he has a sense of confidence or self-efficacy, he could focus on gaining satisfaction when he felt that students were learning. So through this study, I found that there are relationships between some of these ideas. In particular, the study shows the importance of autonomy and discontentment, which, as a reminder, is thought to be important for instructors to engage in professional development and try out new teaching practices. So our next steps include collecting data to try and understand if GTA's perceptions of discontentment, autonomy, and self-efficacy are important for them to engage in professional development opportunities to support their teaching practices. Thank you so much for listening.
Hello, my name is Carly Altman. I'm a third-year doctoral student, and this is my most recent research. Suicide is the second leading cause of death for persons aged 10 to 34. Additionally, individuals in the agriculture industry face higher rates of suicide and depression. This study is motivated by the awareness of suicidal ideation in agriculture with additional emphasis by university. In 2021, a survey was distributed to 1,900 university students with a 16% response rate reporting thoughts of suicide. This study investigates thought of belongingness, defined as having a low sense of acceptance, and perceived burdensomeness, defined as feeling taxing onto others. Using the interpersonal needs questionnaire, we investigated students' age, gender identity, academic rank, employment status, living situation, tuition responsibility, and social media use. The research questions were: to what extent do undergraduate agriculture students experience thought of belongingness? To what extent do undergraduate agriculture students experience perceived burdensomeness? Are undergraduate agriculture students' feelings of thought of belongingness associated with perceived burdensomeness or any stressors? Are undergraduate agriculture students' feelings of perceived burdensomeness associated with thought of belongingness or any stressors? This study uses the interpersonal theory of suicide to position the research with linear constructs of thought of belongingness and perceived burdensomeness, and a third construct related to the capability to conduct self-harm. The interpersonal theory of suicide was used to develop the interpersonal needs questionnaire. We conducted a random sample of undergraduate agriculture emails and selected 196 students. Due to incompletion, only 25 responses were used for analysis. Survey questions include the 15-item interpersonal needs questionnaire with 9 demographic questions. The interpersonal needs questionnaire had a 9-item associated with thought of belongingness and 6 items associated with perceived burdensomeness. To answer research question 1, undergraduate agriculture students' experiences with thought of belongingness is varied but low. To answer research question 2, undergraduate agriculture students' experience with perceived burdensomeness is low. To answer research question 3, authority belongingness is positively associated with perceived burdensomeness. Individuals experiencing higher levels of authority belongingness tend to feel more burdensomeness. Employment status was also positively associated with perceived burdensomeness, with employed individuals reporting higher perceived burdensomeness than their non-employed counterparts. To answer research question 4, perceived burdensomeness was positively associated with authority belongingness, suggesting that individuals with higher perceived burdensomeness tend to experience higher levels of authority belongingness. Age was also a significant predictor, with individuals under 24 reporting lower authority belongingness scores. Employment status was inversely related to authority belongingness, with employed individuals reporting significantly lower levels. Additionally, living at home was positively associated with authority belongingness, suggesting that individuals residing at home may experience increased feelings of authority belongingness. One implication of the study is the small response rate. Therefore, the results of the study are not representative of the population. Thank you for your time.
Hello, my name is Chris Bonison. I'm a PhD student in the Math Education PhD program here at MTSU. I'm interested in how people view the nature of mathematics, which sounds like a very philosophical topic, but it's also relevant to the field of math education because how teachers view the nature of math influences how they teach, and how students understand the nature of mathematics influences their experiences in the mathematics classroom. So I'd like to present the results of a pilot study I did earlier this year. I developed a survey to measure undergraduate views of the nature of mathematics. It consists of 12 Likert scale questions and some demographic information as well. I implemented this survey to 65 undergraduate students in mathematics courses here at MTSU. A sample question from the survey is down at the bottom right. When we observe mathematical relationships in nature, it is because either we are projecting mathematics onto nature or mathematics is inherent to nature. So the participant can respond with a number 1 through 7, depending on where they fall in that spectrum. And the results for my 65 participants for this question are in that chart on the bottom. So now I'd like to talk about the chart on the left. Once I got my 65 survey responses, I did what's called latent profile analysis on the results to look for different clusters of people based on how they responded similarly to the questions on the survey. So here I will point out there were 3 dimensions that the survey measured. The first one is internal versus external, or whether or not math exists internal to ourselves or outside of ourselves. The second one is abstract versus physical. So is mathematics sort of otherworldly and abstract, or is it fundamentally rooted in the physical world? And lastly, conceptual versus symbolic. So is math just a game of symbols, or is it more conceptual and about ideas? So the latent profile analysis reveals how people score on these dimensions in different clusters. So for example, the green group, which was about maybe half to a third of the participants, they were what I call the Platonists. So they have an external view of nom, the nature of math, an abstract view of nom, and a conceptual view of nom. The middle group in red, I call the centrists because they sort of scored in the middle on everything. And the blue group, I call the non-Platonists because they score sort of in opposition to the Platonists. So for my dissertation, I like to do a broader study that includes more dimensions and more participants, but this was a good first step. Thank you for listening.
My name is Christopher Clark, and I am a third-year molecular biosciences PhD student in Dr. Suvik Banerjee's lab. My research is focused on the development of novel Vareblin analogs to act as colchicine binding site inhibitors for the treatment of metastatic melanoma. Metastatic melanoma is a type of skin cancer which is known to be extremely aggressive, has a high mortality rate, and it's hard to treat. Currently, treatment options include targeted therapies and paclitaxel. But unfortunately, the development of resistance to these therapies is common, and there are currently limited options for their treatment. Previous studies have shown that colchicine binding site inhibitors can be used to overcome some forms of drug resistance, most notably to paclitaxel. Vareblin is a previously identified colchicine binding site inhibitor and has been shown to have potent activity against many types of cancer, including melanoma. Despite this, Vareblin failed in clinical trials due to unforeseen toxicity. Therefore, there is an urgent need to develop new inhibitors with less toxicity. My research began with the design and synthesis of 22 novel compounds based on Vareblin. The design of these new compounds was influenced by molecular modeling and previously published X-ray co-crystal structures. After synthesis, all compounds were evaluated for activity against a panel of melanoma cell lines. First, they were tested to see if they can inhibit the growth of these cancer cells in an MTT assay. A total of 11 compounds had notable activity less than 1 micromolar, and our top compound, CJC1DR9, had activity in the 15 to 20 nanomolar range, which is quite potent. We also determined the effect treatment with their compound had on cancer cell characteristics such as morphology, migration, and invasion. Next, mechanism of action studies were performed to confirm that our compound is a colchicine binding site inhibitor. One such assay used was the EBI competitive binding assay, where CJC1DR9 prevented the binding of EBI to colchicine site. Finally, CJC1DR9 was further evaluated in an in vivo xenograft mouse model study. Mice were first inoculated with A375 paclitaxel-resistant melanoma cells to create tumors and were then treated with either vehicle paclitaxel or a compound. Treatment with R9 significantly inhibited tumor growth for 17 days, and additionally, preliminary findings show that our compound induces apoptosis and causes significant immune cell proliferation in the tumor. Further research will be to improve our in vivo efficacy and the water solubility of our lead compound. I look forward to presenting these results next year. Thank you.
Hello, my name is Elena Mancera Andrade. I am a PhD candidate in the Vicar Lab, and our main goal is to discover new antimicrobial compounds. And so why is it important? Well, antimicrobial resistance is a global concern, and especially in the United States, we have around 3 million of infections every year. During the COVID-19 pandemic, the number of infections increased, and unfortunately, even after the pandemic, those numbers remain higher than before for many of the drug-resistant pathogens. One of those is Pseudomonas aeruginosa, which targets immunocompromised people, causing chronic pulmonary infections. And so my thesis project is to find new antimicrobial compounds for Pseudomonas aeruginosa. In order to do that, we are working with molecules called peptoids, which mimic the antimicrobial activity of small proteins found in the immune system. Testing each peptide one at a time will take an immense amount of time to identify an effective drug candidate. Therefore, the Vicar Lab has developed a high-throughput screening technique called the Peptide Library Agar Diffusion Assay. And so this assay can test hundreds to thousands of compounds within just a few days. And so in order to explain this, we have divided the assay into 3 phases. The first one is the design and synthesis of the peptoids. And so let's think of peptoids as building blocks. And so in this part, we determine the length of the building blocks and the type of building blocks that we are going to use. And so we always include building blocks that are cyclic, cationic or with positive charge, and aliphatic or linear. Once we decided this, we synthesize the peptoid into the PlatThinker, which consists of 2 identical peptide strands. The first strand is going to be used for the testing, and the second strand is going to be used for the characterization of the peptoid. So for part 2, we mix the pathogen with the peptoids, and after 12 hours, the peptoids with antimicrobial activity will kill the bacteria and will create this zone of inhibition. Compared to those without any activity at all, they won't show any zone of inhibition. Therefore, after this, we manually remove these possible hits, and then we characterize them by first determining the sequence, the order of the building blocks, and then we calculate the antimicrobial activity and toxicity of these peptoids. And that will be it. Thank you.
Hi, my name is Emily Jolly. I'm a master's student in the horse science program with an emphasis in equine physiology. The study we conducted looked at the ability of novice and advanced Western riders and their ability to identify induced stirrup asymmetry. Previous research has shown the asymmetry of both the horse and rider can have an impact on rider positioning and effectiveness. This raises concerns as an asymmetrical and potentially unstable rider may influence safety and horse welfare. In addition, it has been found that advanced riders tended to be more symmetrical when compared to novice riders. Participant demographics of prior research has mainly included those riding in English tack, with very few using Western tack. For our study, we wanted to utilize Western tack as a way to evaluate a unique sector within the field of equitation science. Other notable features of the study include our riders being blinded and all treatments being randomized, both of which are not as frequently seen with previous research. We took 10 MTSU horses and 10 horse science program riders, with 5 being deemed advanced and 5 deemed novice, and paired them together for this study. We hypothesized that our advanced riders would be able to detect stirrup asymmetry in a greater frequency when compared to our novice riders. Over 2 data collection days, each pair was randomly assigned to a treatment, with one ride being asymmetrical, having one stirrup shortened by 10 centimeters, and the other being symmetrical. They performed the same pattern, shown here, and took a survey at the completion of their ride, answering questions about their ride, how often they ride during the week, and anything they may have noticed about their positioning or stirrups. The rides were also videoed to confirm pattern completion and accuracy. The results of the data showed that differences between advanced and novice riders were fairly close, with 60% of our advanced and 50% of our novice correctly identifying their stirrups. However, 70% of those riding more than 5 hours per week and 50% of those only riding 1 to 2 hours per week correctly identified their stirrups, regardless of experience level. Additionally, 100% of those riding 2 to 3, 3 to 4, and more than 5 hours per week correctly perform their pattern, with only 67% of those riding 1 to 2 hours per week doing so. This leads us to assume that frequency may have a greater impact on stirrup identification, not just riding experience, potentially putting riders at a disadvantage to those who ride more hours per week. Understanding of a rider's perspective of asymmetry is important to the field of equitation science, and the hours that they ride per week may be a contributing factor to accurate stirrup identification. Thank you.
Hi, my name is Erin Scott, and I'm a graduate student in the horse science program concentrating in equine education. My experiential learning project allowed me to partner with the Youth Equestrian Development Association to offer a new format of competition for the youth. Teams from all over the United States compete in the draw format horse shows offered throughout the year. This means that horses are provided by partner teams and local universities, which eliminates the need for participants to own their own horse. The riders are judged on their equitation and ability to navigate the horse they drew through a pattern. YITA is dedicated to giving youth, ranging from elementary to high school, scholarship opportunities and the skills they need to be successful in their future endeavors. I created a new competition that promotes the need for being a well-rounded horseman. The 3-part hippology contest, hippology means the study of the horse, included a multiple choice test, photo identification stations, and judging a class of horses based on the evaluation of their conformation. Participants were also tested on their knowledge of various topics such as health, nutrition, handling, behavior, and physiology. Prior to the event, every pre-entered competitor was given access to a resource packet that I created, which included all the information they needed to ace the test. The first year was very successful, with well over 100 entries who competed. The association was very pleased with this new addition to their national show, and we plan to make it even better in 2025. We are hoping this new competition will continue to inspire young equestrians to be better, more rounded horsemen that can positively impact the horse industry. I think the test and provided study resources will also help all the youth equestrian coaches out there to better prepare their students for their future in the horse industry.
My name is Jiblal Upadhyay, and my research topic is a novel approach for multimodal representation learning in enhancing digital health. As we know, artificial intelligence is transforming every industries, especially healthcare, by analyzing vast data to assist in life-saving decisions. But in the real world, healthcare data often sits isolated in silos. Each dataset containing valuable but incomplete information. For example, diagnosing a patient mainly on their chest X-ray without understanding their symptoms or medical history leaves gaps, much like a puzzle with missing pieces. Until recently, AI has been confined to using only single types of data, providing insights but never the whole story. My research focuses on multimodal representation learning, which seeks to fill in these missing pieces, combining diverse data sources to offer a more comprehensive view with context-driven, potentially leading to better decisions and outcomes. For instance, a chest X-ray alone might reveal signs of pneumonia, but without considering the patient's medical history or lab results, we miss critical aspects of the patient's health. This single modality approach often limits our ability to detect rare conditions such as edema or pleural effusion that requires a more holistic view. This shift from single modality AI to multimodal AI is critical because healthcare decisions rely on multiple data points. I'm developing innovative framework to combine different types of data, what we call multimodal fusion. We design the methods like early fusions, late fusions for our problem study with Mimic CXA dataset. My model doesn't just look at an X-ray, it simultaneously processes the X-rays, the doctor notes, and the lab results. This helps it to see connections that single modality models often misses out. My work goes further by focusing on explainability and the bias mitigation. Think of it as a trusted medical consultant. Not only does it provide a diagnosis, but it also provides a healthcare provider through its reasoning, pinpointing specific areas on the chest X-rays and referencing relevant parts of the clinical reports. This guidance shows which features like abnormal shadows or mild fluid accumulations contributed to the diagnosis. By doing so, the model offers a comprehensive map of the patient's conditions, helping medical professionals make well-informed decisions with greater confidence. With the global shortage of radiologists, they often face the pressure of reviewing and interpreting complex imaging data just in 3 to 4 minutes per case. This time constraint can hinder thorough analysis and potentially negatively impact patients' outcomes. My work aims to ease this burden, providing radiologists with advanced tools to augment their diagnostic accuracy and efficiency. In sum, I can say multimodal representation learning is therefore not just a medical advancement, it's a paradigm shift in how AI contributes to complex life-saving decisions. Thank you.
Hi, my name is Kara Brown, and I'm a master's student here at MTSU with a concentration in econ education. And today we'll be talking about creating and hosting a horsemanship clinic program and show management at youth competition. Youth involvement in horses has proven to aid in developing life skills such as decision making, goal setting, and self-discipline, increasing science-based knowledge and developing characteristics like self-esteem, confidence, and passion. Horsemanship clinics are a setting where equine industry professionals are able to teach riding techniques that better communication between horse and rider. Riders of all levels and ages can participate in this educational opportunity that includes a riding as well as classroom portion. MTSU saw a need for horsemanship clinics in the Tennessee area, and they wanted to fill that. By doing so, they created a survey that asked questions of location, age, and discipline, as well as if they had an appropriate facility, insurance, and could cover the included fees with our clinics. Following this, we created an application for interested parties to apply to host a clinic. Once accepted, we then assign instructors based upon clinic needs, and these instructors are equipped with riding and classroom lesson plans. This comes from banked curriculum created by our master students here in the program. In addition to the Horsemanship Clinic project, MTSU and the Interscholastic Equestrian Association partnered to allow me to intern with them at their national show working in their paddock area. In this position, I was able to work on my networking skills, building broader connections in all areas of the equine industry, as well as being able to see draw-based format coaching in action. These will help benefit my education by seeing examples of more draw-based format coaching, as well as gaining experience in running a national level draw-based format show. Thank you.
Have you ever struggled to have a productive conversation about a controversial science topic like vaccines or climate change? Research shows that our undergraduate biology students are also actively having these conversations, and they're struggling too. They're using ineffective tactics like arguing and only using facts, and then they're telling us they're not prepared to have these conversations. So, we wanted to see what we could do to support these students so that they can communicate about science more effectively with their communities. We implemented 1 hour of science communication instruction in our introductory biology course to train our students to talk about controversial science topics, and then we studied how it impacted the ways they talked about science, both in class and real-world conversations. So first, we asked our students to write down on a worksheet what they would say to someone who told them humans weren't causing climate change. Then, we provided them with our instruction on how to communicate effectively, for example, by establishing dialogue and establishing relationships with another person. Then, we asked them to write a brand new response to that same person who didn't think humans are causing climate change. Then, we wanted to also test if they could apply their skills to a new topic, so we asked them what they would say to someone who was vaccine hesitant. Later, we analyzed these worksheets to see what effective and ineffective science communication strategies they used. We saw that the number of students who tried to build relationships and have a dialogue increased dramatically after instruction, and this carried over from climate change to vaccines too. And the number of students who used the deficit approach, or relying only on facts and hoping they'll change the other person's mind, dropped drastically after instruction. Now, since these were just in-class worksheets, we also wanted to know how it impacted their real-world communication. So we interviewed our students the following semester to find out how instruction had changed their views of science communication and their real-world experiences. Students told us that before instruction, they thought people would just automatically understand something if you showed them a good infographic. But now they talked about how effective conversations needed to be a two-way street. And their experiences matched this too. Students had described moving from arguing and calling people stupid before instruction to building relationships and having productive dialogues after. And our students talked about how our instruction not only made them feel more confident, but also more willing to go out and have these crucial conversations. So we straw that even one single hour of science communication instruction in an introductory biology course can not only positively impact our students' communication skills in class, but it also had lasting impacts that allowed our students to become better science communicators in their daily lives. So, if more instructors could implement instruction like this in their science courses, we might be able to empower our students to become better communicators to help build more bridges between science and society.
Hello, everyone. My name is Kingsley Adamwa, and I'll be presenting my dissertation thesis on student limit conceptions and representation approaches. Imagine as an instructor of Calculus 1, you walk into the classroom and ask a student what is the understanding of the limit concept. And the student tells you that whenever they think about the limit concept, they think is going to take some form of a graph or a table. Now, this was my own experience in a math class as an instructor. And so based on this, I decided to move forward by, first of all, digging into literature to see what has been done. And I found that little descriptions are available on how students view and represent the limit concepts. And these studies have actually looked at this from a deficit perspective of students' understanding of limits. But I am interested in this from an asset-based perspective, more specifically, the type of connections that exist between their views of limits and the type of representation approaches they prefer. Now, moving forward with this, I provided surveys to 3 Calculus 1 classes for a total of 63 students to complete. Now, after the surveys were completed, I followed up with interviews for 15 of the students that were purposefully selected. Now, the results for this study clearly indicates that students thinking and reasoning about the limit concept have some form of connection with the specific types of representations they prefer. For example, graphical, numerical, or algebraic. Now, apart from these connections, they also provided reasons why the representation approaches really help them to provide to have a better thinking and understanding of the limit concepts. Now, the results of this study is actually meant to inform calculus instructors on the need to leverage on multiple representations to move students' ways of thinking and reasoning forward in any mathematical concept. And this can actually be applied to other disciplines of STEM. I hope these results will help you as an instructor and in the field to move the field forward in thinking about helping students learning and understanding of any concepts. Thank you.
Hello, my name is Lala Yamazaki, and I'm a graduate student in data science. Today, I'll be presenting my research on exploring transformers and machine learning techniques for health data classification. This study focuses on using artificial intelligence to classify physiological signals to gain insights into stress and mental well-being. The motivation for this research comes from a need to understand how stress affects performance and mental health, particularly in high-pressure situations like exams. Physiological signals collected from wearable sensors provide insights into these stress responses. My objective was to determine if advanced AI models, especially transformers, could improve the accuracy of predicting stress levels and possibly outperform traditional machine learning models with potential applications in mental health support. Transformers are state-of-the-art models initially developed for natural language processing in models like GPT. Their self-attention mechanism enables them to capture complex dependencies. My goal was to explore whether this power could transfer to numerical data, specifically physiological signals, to capture stress patterns, and to see if transformers could outperform traditional models in this domain. For this study, I used data collected from students wearing physiological sensors during exams, which captured electrodermal activity, heart rate, skin temperature, blood volume pulse, and accelerometer data. I tested 3 models: logistic regression as a baseline, random forest known for handling nonlinear relationships, and transformer model adapted for numerical data. The random forest achieved the highest accuracy at 97%, with 3 key signals playing the most significant roles. They are electrodermal activity, which measures skin conductivity with higher levels during exams, indicating stress or intense focus; accelerometer data that tracks physical movement, where increased activity may signal anxiety; and skin temperature, which tends to drop under stress due to blood flow changes, indirectly signaling mental strain. As for the transformer model, it showed impressive results, achieving a high accuracy of 90%. While it didn't quite match the random forest performance, the transformer's ability to capture complex patterns is promising, suggesting potential for future applications in mental health monitoring. In conclusion, this research highlights the potential of AI and machine learning models like transformers for real-time stress monitoring, paving the way for mental health applications in high-pressure environments. Thank you very much.
If we all measured this plant, would we all get the same answer? How would we know for sure its true height? These may seem like simple questions, but they require students to think about how the plant is measured. Do I measure the pot? Which leaf should I choose? How to use the measuring tool. How will I line up my ruler? Should I use centimeters or inches? How to organize the data, and how to determine and justify their best guess for the height. All these decisions are necessary for students to make sense of the data they collect and the phenomena they are measuring. My work explores how the questions teachers ask help students make sense of data in their investigations in math and science classes. To do this, I study how experienced 6th grade math and science teachers ask questions during their data investigations, like this one with the plant. I also build questions I hypothesize may help students to make sense of data into lesson plans for data investigations, and study how 6th grade students respond to these questions. My initial work suggests that to help students make sense of data, teachers could ask questions that point out puzzling aspects of the data to invite students to develop their explanations? Questions that make connections among the phenomenon being measured, the way it was measured, and the data itself, and questions to help students make sense of data practices. For example, which measure of center, the mode, the median, or the mean, should we choose, and why would we choose it? Questions are a critical teaching tool, but asking the right question at the right time can be difficult. I hope my work gives teachers insights into how to ask questions when they are doing data investigations, and ultimately help students to develop the skills to make sense of data like STEM professionals. Thank you.
Hello, everyone. My name is Mary Tran. I work with Dr. Kevin Bicker in the chemistry department. Today, I'm excited to share my project on optimizing antifungal peptoids for Candida albicans through SAR aspiration. Candida albicans is a fungal yeast that normally colonizes the skin and mucosal surfaces, but under certain conditions, it can transition into a pathogen, causing several infections, particularly in immunocompromised individuals. A major public health concern is Candida albicans are increasingly resistant to current antifungal treatments and has been highlighted by the CDC as a critical fungal pathogen. They are responsible for approximately 25,000 infections per year in the United States, with a mortality rate ranging from 30 to 60%. Our lab focuses on developing peptoids as potential antifungal agents. Peptoids are structural analogs of peptides, which are well known for their antifungal properties and broad bioactivity. But unlike peptides, peptoids have their R group or their side chain attached to the nitrogen atom of the backbone rather than the alpha carbon. This slight modification allow it to be resistant to enzymatic degradation and enhance cell permeability. Previously, our lab has identified an antifungal peptoid called RMG9-11 through a high-throughput screening assay. My study builds on this discovery by conducting a structural activity relationship analysis to enhance its antifungal properties. But to optimize RMG9-11, I tested the pharmacological significance of each of these submonomers to identify the structural groups that are responsible for antifungal activity and cytotoxicity. And I lead with 4 rounds of systematic modification. First, I replaced this phenylethylamine with these 9 different amines in its position, ran its activity testing in cytotoxicity. For round 2, I substituted the benzylamine group with 9 additional amines and evaluate these derivatives. For round 3, I modified the furflamine group, testing 15 amine substitution. And lastly, I replaced the propylamine group with these 6 different amines in this position and ran testing. In addition, I created hybrids modification by combining promising features from different rounds. So overall, I synthesized and tested 50 derivatives of RMG9-11 and was able to discover 5 new antifungal peptoids with improved activity against Candida albicans. Thank you.
Hello, my name is Oladuni Oyedotun, and today I'm going to be discussing my research work titled Exploring the Complex Interplay of Demographics, Social, and Environmental Factors on Maternal Health, a Causal Loop Analysis. Maternal mortality rate is an important indicator of the state of well-being of any population. Globally, the United States is among the nations with the lowest maternal mortality rate. But when compared with the counterpart developed countries, the US has one of the highest maternal mortality rate, with over 800 women dying from pregnancy-related conditions yearly. This is an alarming rate, and 50% of causes are preventable. Although several studies have been done to show the causes of maternal health, and over the years, lots of funds have gone into improving maternal health in the United States. However, maternal health issues are complex, as factors affecting maternal health do not stand alone, but interact dynamically within a larger system that affects maternal health outcomes. This system dynamics approach is provided by the causal loop analysis, which this study is based on. It also sets the stage for system dynamics modeling later on. Now, in this study, a comprehensive literature search was done to identify factors affecting maternal health, and this was developed into a causal loop diagram using the Vensim software. From the analysis, it's seen that structural racism and gender inequity significantly affect maternal health by limiting access to education, health insurance coverage, availability of health care, and stable housing. Also, we see that maternal education is shown to improve maternal employment and as well as maternal income, and also the possibility of getting paid maternal leave, which then improves access to care and in turn improves maternal health outcomes, which formed a positive reinforcing loop. Also, we see that intimate partner violence, low social support, both of them were shown to undermine health-seeking behaviors and maternal health service utilization among women. Now, looking at all these things, all these factors, we can conclude that in order to improve maternal health outcomes, there is the need to intensify efforts in addressing systemic inequities so as to improve access to healthcare for all. There's also the need to empower women through education and economic stability, as well as address psychosocial issues such as intimate partner violence. Thank you.
Hi everyone, I'm Pratik Rai, a second year molecular biosciences PhD student here at MTSU, and I'm thrilled to share my work with you today. Let's start with a problem we are all familiar with, cancer. Cancer is, in essence, your body's own cells turning rogue, growing uncontrollably and even invading distant parts of the body. Now here is a twist. Cancer cells are not only deadly but also very smart. Cancer cells have an uncanny ability to adapt and resist the treatments we develop, such as chemotherapy and radiotherapy. In fact, a 2019 report by the FDA revealed that 90% of cancer-related deaths occur because of drug resistance. Sometimes this resistance is already present in cancer cells before treatment. This is called intrinsic resistance. But most of the times, resistance develops during treatment because the cancer cells find clever ways to adapt. This is known as acquired resistance. My work focuses on a specific pathway in cancer biology known as the autotaxin LPA signaling axis. Imagine cancer cells as soldiers on a battlefield. They need to communicate to coordinate their survival tactics. The signaling axis acts like their messaging system. Here is how it works. The enzyme autotaxin produces a molecule called LPA by converting a precursor molecule called LPC, which then binds to proteins on the surface of cancer cells called GPCRs, triggering a chain reaction of signals inside the cell. Our hypothesis is simple. If we can disrupt this messaging system, we can weaken the cancer cells and make them more vulnerable to treatment. But how do we achieve this? By targeting the proteins like autotaxin and LPR1, we can potentially cut the wires in this communication system. Proteins are like tiny machines in our body, and their structure determines how they work. If we can find small molecules that bind to these proteins and mess up their structure, we can stop them from functioning properly. But here's the challenge. There are millions of potential molecules out there. How do we identify the right ones? This is where computer-aided drug design comes into play. Think of computers as super-powered microscopes combined with predictive brains. They allow us to visualize how small molecules might interact with proteins at the atomic level, and we can simulate these interactions to predict which molecules might have the potential to disrupt this autotaxin LPA pathway. Through this approach, we identified two molecules that looked very promising. We then tested these molecules in the lab using a model of late-stage breast cancer, specifically 41 cancer cells. Here's what we found. When we combined our molecules with a well-known cancer drug called paclitaxel, the results were remarkable. Not only did the combination work better than paclitaxel alone, but it also overcame resistance in cancer cells that paclitaxel could not kill on its own. This combination strategy, known as the synergistic therapy, enhances the effectiveness of existing drugs. What's even more exciting is that our molecules don't harm healthy cells. They specifically target cancer cells and enhance the effect of existing treatments. In short, we are not just fighting cancer, we are outsmarting it. Thank you so much for your time and interest. Together, we can reimagine how we fight this deadly disease.
Have you ever wondered how we know if students are really learning? It's not just about memorizing the facts, it's about connecting ideas in meaningful ways. Imagine trying to understand something as complex as evolution by natural selection. To truly explain it, we need to connect different pieces of knowledge like genetic variation, heredity, and survival of the fittest. Now, imagine being a teacher trying to figure out what students actually know or understand. How do we make sense of their answer? And how do we see if they are connecting the dots or just listing the facts? Same for being a qualitative researcher, how to analyze if some ideas are connected to another ideas, and how to illustrate the connections to reveal deeper meaningful pattern. So to solve this problem, I create the R package as a tool to help visualize concepts that students know or how the concepts are related to one another. It's like creating a map of students' understanding, not only show what they learn, but also show how well they connecting the key concepts. Here's what this tool can do. Imagine students are describing what they know about species, where each student might mention up to 5 concepts. So using this tool, we can generate a co-occurrence matrix. It will show how often two ideas appear together, so it can help us to see which concept students frequently connect. And then it can create bar plot, a simple graph that show how often each concept comes up to highlight which ideas students understand well and which need more attention. And then it also can show the correlation matrix to reveal how strongly different concepts are related in students' thinking. And the last is to illustrate the concept network as a powerful feature there. A network graph here can be seen in the circle where it's represent the concept, which a bigger circle show a concept that come up more often, and a row between them show the frequency of students connect those ideas. So the thicker arrow means the stronger connection. Now, why this is better? By seeing students struggle to make connections, then teacher can adjust their lesson to better support learning. And researchers can also use this to illustrate patterns in their data in more meaningful way.
In mathematics, proofs are explanations based on logic and known facts of why a mathematical statement is true, similar to how one might convince someone of their argument by carefully laying out all the facts. While proof has only grown in importance to mathematics and many other STEM fields, students still struggle to authentically prove. Proof education researchers have concluded that one of the main reasons why novice provers often struggle to prove is due to their success or lack thereof in appropriately using mathematical definitions in their proofs. While research suggests that student success in appropriately using definitions may be tied to their conceptions, there exists little research detailing what conceptions novice provers have about the function of definitions, and even less research exploring how these conceptions influence how they engage with and use mathematical definitions in their proving. In a pilot study of 2 undergraduate Introduction to Proof courses, I collected students' written responses to a prompt that asked them to describe the function of definitions either generally or specific to their course-related proving experiences. I inductively coded students' responses and generated 10 themes describing students' conceptions of the function of definitions in proving. After deductively coding student responses, I was surprised to find that novice provers most frequently emphasize a conception of definitions as an operationalizing tool, providing something students could operate on within their proofs, akin to the manipulatives one might find in a K-12 mathematics classroom. In describing his conception, Sean said, "In class, when we attempted to prove that the sum of 2 rational numbers is rational, the definition was our cornerstone. It wasn't just about stating the properties of rational numbers, it was about manipulating and applying them to form a coherent and sound proof." Another surprising find was the sophisticated conception novice provers held about the function of definitions as a tool for generalization and for gaining better understanding in proving. This is best represented by Eleanor's quote: "The function of rational numbers serve a primary purpose in my proof writing because it helps with divisibility problems. The definition also helps when you are working with a statement claiming variables as rational numbers." After hearing their conceptions, we would want to imagine two things. One, what would be the difference in how both students would engage with mathematical definitions? And two, what success would we imagine each of the students would have in their individual proving? It is for this reason that I have dedicated my dissertation research to exploring students' conceptions of how definitions function in proving and how it may influence their proving success, so that I and many other proof instructors can leverage our students' conceptions into their development as authentic provers.
Every second, we lose a football field's worth of forest. This is happening at an alarming rate in places like Amazon Basin, the Congo Basin, and the forest of Indonesia. But it's not just about losing trees. Deforestation accelerates climate change, destroys habitat, and disrupts the livelihood of local communities. Monitoring these changes is critical. But there are big challenges: privacy concern, fragmented analysis, and centralized systems. If we are going to protect our forest, we need a solution that supports global collaboration while also preserving data privacy. This is where the federated learning, or the FL, comes in. FL is a reversionary machine learning approach that allows model to be trained collaboratively without ever sharing the data. Unlike traditional machine learning, which centralizes all data in one location, FL trains model locally on the data within each region. Only the learned insights are shared with the central server. This makes it private, collaborative, and efficient. By combining federated learning with satellite imagery, my research offers a transformative way to track and even prevent deforestation on a global scale. Let me explain how the system works in 3 steps. Local training. Each region processes its own satellite imagery locally. For this step, I use a model that identifies deforested areas using the UNET model. Federated aggregation. Instead of sharing raw data, regions send updates from their trained model to the central server. These updates are then combined to build a global model. A global refinement. The improved model is sent back to all the regions, enhancing its accuracy for diverse ecosystem. This system achieves a balance between privacy and collaboration, creating a powerful tool to detect and predict deforestation patterns. The initial results are promising. My model achieved a 97% accuracy and 98% validation accuracy, a strong indicator of its ability to detect deforestation patterns. As I continue refining the system, I expect even more exciting results. For example, we aim to identify high-risk areas for proactive interventions and provide better insight for both global and local conservative efforts. Deforestation is a global crisis, but federated learning offers a global solution. By enabling regions to collaborate securely, my research bridges the gap between privacy and effective monitoring. This approach empowers policymakers and scientists to act faster, more accurately, and more collaboratively. Together, we can protect our forest and secure the future of our planet. Thank you.
Hi, my name is CBAS Zimmerman Cameron, and I'm a master's student here at MTSU with a concentration in equine physiology. Today, I'll be talking about the effect of palmar digital perineural analgesia as a model for nerving on forelimb loading over varied surfaces at the walk and trot. Essentially, what this study was looking at was the effect of football dynamics on the front limbs of horses over varied surfaces at the walk and trot, pre and post nerve blocking. Nerve blocking is the temporary removal of sensation to the heel region of the hoof, which is being used as a model for nerving. And nerving is the complete removal of a sensation to the heel region of the hoof. And why we are looking at this specific study is because of navicular disease. Navicular disease is one of the most common lamenesses seen in horses, and is the degeneration to the navicular bone, which is very painful. And nerving is used to treat navicular disease to allow horses to still compete and continue with daily use without pain. In this study, what we did was we used 3 horses, and we took these tech scan sensors and cut them out to the shape of the hoof, and attach them to the hoof via a glue-on shoe. And here you can see the entire setup with the sensor and this box. This box will send the sensor information to this computer, which is looking at the area, pressure, and force. And in this study, all 3 horses completed the same exercise pre and post blocking, which was to walk and trot over a hard surface, which was this rubber mat flooring, and a soft surface, which was an arena clay footing. Once all of those recordings were complete, we could continue on with our data analysis. And so far, what we have seen was that there was a difference post-blocking in hard ground. We saw that there was more area loaded post-blocking on the hard ground surface. And once the other data analysis is completed, it can give owners, trainers, veterinarians, and the equine industry as a whole a better understanding of what exactly happens to the hoof after nerve blocking, and it can give us a better idea of what we should be doing for welfare and management practices for our horses. Thank you.
Hi all, I am Tanya Grain, a second-year MOBI PhD student working in Dr. Shavik Banerjee lab in the Department of Chemistry. I'm excited to share my work with you all today. We all are aware about one of the major diseases existing amongst us, cancer. A living body, especially that of an adult human, is made up of trillions of cells, and all these cells undergo division periodically to keep up with the demands of our body. This cell division happens in a regulated manner, and many proteins and enzymes of our body work together to make sure the process of cell division happens smoothly. One such protein, which is found in an animal cell, is tubulin. It is composed of 2 different subunits named as alpha and beta. When these subunits come together and polymerize, they form a hollow cylindrical structure called microtubule. This microtubule is very important and has a variety of functions like cell growth, movement of cells in the body. It also helps in movement of molecules in a cell and cell division. How exactly it helps in cell division? Well, microtubules are always in a dynamic state. When these alpha and beta subunits come together and polymerize, they help in microtubule growth or polymerization. After a point, the beta subunits start falling off from the microtubule end, leading to depolymerization or shrinkage of microtubule. This to and fro movement of microtubule is called dynamic instability, and this phenomenon makes the microtubule flexible enough to stretch and shrink across the cell and divide it into 2 daughter cells. Now, as we were listening that unregulated cell division is a hallmark of cancer, that means targeting microtubule of a cancer cell can stop them from aiding the process of rapid cell division. We can either arrest the microtubule in a polymerized state by using drugs that inhibit depolymerization, or we can arrest the microtubules in a depolymerized state by using drugs that inhibit polymerization. How do we differentiate between these 2 drugs? A protein has several sites that has affinity for different types of molecules. These sites are called binding sites. This microtubule protein also has different binding sites, and depending upon which we are targeting, we can produce different classes of these drug molecules. In my project, we try to develop new compounds that inhibit microtubule polymerization and eventually leads to cancer cell death. We perform a series of biological experiments to confirm if our compound is actually doing what it is intended to do. For example, one of our compounds, TGA188, abbreviated as such, showed that it was bioactive in cancer cell line, showing an inhibitory concentration of about 100 nanomolars. This experiment, which is also called as cell cycle analysis, over the right side of the presentation, showed that our compound was stopping the cancer cells from completing the cell cycle and was arresting the cells in a pre-division state. So that was all from my side. Hope you all liked my work and found it interesting. Thank you so much.
Hi everyone, my name is Yusuf Halik and I am a computational and data science PhD student here at MTSU. Today I'd like to present my research on predicting Beijing air quality using linear and nonlinear methods. The city of Beijing is located in China and has suffered from a significant decrease in air quality over the last 30 years. 4 years worth of Beijing air quality was recorded and made publicly available for analysis. So our research has 3 objectives. The first is to identify the main contributing factors in Beijing air quality. The second is to explore the efficacy of linear versus nonlinear methods in approaching this problem. And the third is to accurately predict Beijing air quality given a set of variables. Now, what do I mean by linear and nonlinear methods? Well, a linear method is basically like drawing a straight line through a set of data points to find patterns. They're pretty simple and pretty predictable. They assume that a change in one factor causes a proportional change in another, just like if you earn $10 for every hour you work. Nonlinear methods, on the other hand, are like trying to fit a squiggly line through the data points. It's like trying to predict the path of a roller coaster. They handle much more complex relationships where small changes can lead to big differences. For example, the way weather can suddenly change due to multiple interacting factors. This leads us to our problem in predicting Beijing air quality. We used a data set that consisted of 10 variables, 4 pollutants and 6 meteorological. The pollutants are sulfur dioxide, carbon monoxide, ozone, and nitrogen dioxide. I wasn't particularly gifted in chemistry, but all we need to know is that these pollutants are harmful to inhale and are generally produced by cars, power plants, and burning coal or oil. The 6 meteorological variables are temperature, humidity, wind speed, wind direction, air pressure, and rain, which are all self-explanatory. Aside from these 10 variables, we have our variable that we want to predict, which is something called PM 2.5. This stands for particulate matter of 2.5 microns in diameter, basically tiny particles in the air that can enter your lungs and even your bloodstream when inhaled. So we compare the performance of 5 linear and 5 nonlinear methods. The performance is quantified by something called the MSE. Essentially, a smaller MSE indicates a better prediction. So you can see that all of the nonlinear methods perform much better than the linear ones, with a particularly advanced method, the LSTM, performing the best. Some problems are so simple that you wouldn't use such an advanced method. For example, you wouldn't fly from Murfreesboro to Nashville, you would drive. So for this data set and problem, it was clear that we needed a more powerful and more advanced technique. Through these methods, we were also able to find that carbon monoxide was the most significant contributor to 2 PM 2.5 by far out of all of the variables. And ultimately, a study like this can help influence policies in Beijing or any city where the study is conducted, and also increase the public's awareness of the importance of air quality, hopefully thus improving the quality of life for all inhabitants. Thank you so much, and I hope you enjoyed this research.